first thing that I've got for you that's going to be important in our notes is the equation of a circle in radius form. Equation of a circle. I don't know why I wrote all that. I normally don't. CLE. Alright. X minus h squared plus y minus k squared is equal to r squared. We know that r represents the radius of our circle. It's r squared there, so that's going to play an important role. And the center of our circle is going to be at hk. Now notice in the center of our, where I wrote this here, this is the center. I put a positive h and a positive k, and up here in the formula they got minus signs in front of them. So that means when we pull to our center, we'll take the opposite sign of what's given there. Okay? Now, characteristics about a circle, we know that all the points on the circumference of the circle are equidistant from the center. That's going to be important to you when you're trying to, because later in this unit we'll have to identify just by looking at the equation whether or not it makes a circle or an ellipse. An ellipse we know is kind of like an oval type shape, something along those lines. And so they're not, all the points are not equidistant. Okay? So that's going to play an important role in how we decide if it's whether a circle or an ellipse. Okay, so here I've got, I got the formula there that you need. Here I've got x squared plus y squared equals 16. We're going to figure out some stuff about this circle and graph it. X squared, as soon as that gets there, x squared plus y squared equals 16. Alright, now, it doesn't look exactly like the equation that you just wrote down, but it is. What's the h and k on this one if there's nothing being added or subtracted to the x and the y? Very good, Devin. So that means our center is at 0, 0, because it doesn't have x plus or minus anything, which is 0. It doesn't have y plus or minus anything, which is 0. So this is going to be a good old circle at the origin where is our center. Now, the radius. What will the radius of this circle be? Not 16. 4. Remember, this is the radius squared. So we take the square root of that and our radius is 4. Okay, so from this point, anywhere I go to the edge of the circle has to be 4 units long. So what I do when I have to graph this, and a good idea for you, would be just to go 4, 1, 2, 3, 4, in every direction and make you a little tick mark so you'll know that's what you've got to go through. This is going to be a giant circle, the way I drew it. Okay, so I know I'll have to hit those. Now I got fancier toys than you do. So I can make mine pretty good. Probably is a little bit, Zach. Yeah, that's what mine would look like if I didn't have the fancy stuff. Let me see, Leah. That's sorry. Alright. Good on that? We'll do another one where it's not at the origin to let you see what one of those looks like. Here's pretty good, Louise.
She's the problem.
We all do.
I do for sure. I do. My sister has 3 of those huge monsters that she's going through.
Well, that's not stop your heart.
Her heart is going to explode.
Yeah.
You know what's that?
And those fill brain cells.
Okay, this time, this time I've given you the center. The center of my circle is at 3, -2, and the radius is 4. The directions this time say find the equation of the circle and then graph it. Okay, so the equation is going to start off that first thing I gave you on the first page. So I'm going to have x, it's a 3, that's my h, so it's going to be minus 3 squared, and then plus y, and I got negative 2, so minus negative 2 is plus 2 squared equals 16. Very good. Okay, now that doesn't help me graph it. I could have graphed it just fine from this stuff they gave me, but they told me to write the equation, so there I did. I wrote the equation. Alright, so to get to my center, I'm going to go right 3 down 2. I want to count, since I'm going to be down here in this quadrant, I'm going to count on the ever line this time. 1, 2, 3, 1, 2. Now from that point is where I'm going to use my radius of 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So that's what I've got to connect there to make my circle. Something like that. You know what this study of circle and ellipses, what this is called?
Circleology.
That's pretty good, but no. It's pretty good, but no. It's conics. And the only reason I'm telling you that is because I'm a math teacher, and I didn't know that until I'd already been teaching math like 10 years. I was asked when I'm doing my unit on conics, and I was like, what? Am I supposed to do a unit on conics? They're like, oh yeah. And I was like, guess I need to add that. So I looked it up and I said, oh, I already did circles. I felt like about a stupid idiot, but
That's what I would have done.
Yeah, I would call it circleology.
I like that better. So it kind of reminds me of Scientology when you say it like that. Can't teach that. Okay, now this next equation that I'm going to give you is not in the form. So we got to do some work with it to get it into the right form so that then we can tell what the center is. Is everybody done with that there?
No.
All right, I can go back. There you go. I needed to have made that circle bigger. I'd have hit the points better. All right, we good? We did the opposite. I drew the first one big and you drew it little. I drew the second one little and you drew it big.
Mine looks like a football. It started off with
Show me those football circles.
it's okay.
It is.
That one doesn't look right. Yeah, okay, if you got
Okay, so here's what we got on this one. X squared plus y squared plus 6x minus 4y minus 51 equals 0. Okay, so that's obviously not in the x minus h squared plus y minus k squared form. So to get it, to be able to tell what our center is, we've got to get it there. Okay, so first thing, what we're going to do, and we've done this before, we didn't spend a lot of time on it because we don't like it, but we're going to have to, we don't have a choice, we're going to have to use the method called completing the square to get this to look like we want it to. Okay, so the first thing I'm going to do in completing the square is if I have any kind of constant on the left side, I'm going to move it over. So right now my negative 51 is a constant. Constant means it doesn't have a variable. So I'm going to move that over. Since it's a minus 51, I'm going to add it. Okay, now before I rewrite the rest of this left side, I'm going to move my x's next to each other and my y's next to each other. Would that be okay if I do that? So I'm going to write x squared. I'm going to move this 6x over here closer to that. And then I got a y squared. And then there's my negative 4y. And then I'm equal to 51. Okay, the reason what we're trying to do is called completing the square is because in that form for a circle, those are perfect squares. That x minus h squared, that's a perfect square. So we're trying to get this thing to be perfect squares. Remember when we did, if I look only now at my x section first, so there's my two x's. When we did completing the square before, this x squared, my a would be 1. This x, my b would be 6. So I need a c that's a perfect square. Bless you. So we get our C by taking our B, half it, and square it. Okay, so my B is 6, so 6 divided by 2 is 3, and 3 squared is 9. So I'm going to add a 9 to this x section. So I'm going to have x squared plus 6x plus 9. Now, if I add 2 there, where do I also have to add it? To the other side, right? You can't just magically put plus 9s in there without some kind of math rules. Okay, now on my y's, I'm going to do the same thing. So on my y's, I'm going to have plus y squared minus 4y. That b is negative 4. So if I half that, I get negative 2. And when I square negative 2, I get 4. But if I add 4 there, got to add 4 to the other side. Okay, purpose in doing all that, remember we're trying to get it into something that looks like that. We can do that now. Because what factors of 9 add to 6? 3 and 3, which so that would be the same as x plus 3 squared, right? What factors of 4 add to negative 4? Negative 2 and negative 2. So that would be the same as x minus 2 squared. Very good, Zach. So here, 51 plus 9 is 60, plus 4 is 64. So do we have that so that we can identify a center and a radius yet? Yes. What is our center? Good. Everybody see what Valentina and Shelby Louise said on that? Remember, it's the opposite sign. So what's our radius? Very good, Leah. It is 8. Square root of that. So you're going to want to remember, how did I figure out that I added 9 and added 4? You're going to want to remember that we took half of our b and squared it. So over here where I wrote that, where my mouse is hovering, that'd be pretty important for you. Okay. Yeah, why not? Let's graph that. I'm going to go to a new page to get my graph paper. Had a center at 3, negative 2. Is that right? 1, 2, 3, 1, 2. This one had a radius of 8. The center was negative 3, 2. So I went the wrong way, so y'all are right. Center was negative 3, 2. So I got to fix mine. I went the wrong way. 1, 2, 3, 1, 2. That's what Louise was fixing me up. Alright, then from there its radius is 8. Square root of 64 is 8, right? 1, 2, 3, 4, 5, 6, 7, 8. 2. That looks good, Shelby Louise. Looks good. Make sure you label that as the circle page because your circles look a lot like ellipses that we're fixing to do.
Yeah. The first one was my dad.
Ellipsis was a moon.
Yep.
That's neat. It's a car.
Oh my gosh, they were both just so wrong.
One of the bell ringers I was making for this, I said eclipse on accident. I said, oops. Look at Zach paying attention, being smart today. I'm proud of him. One day at a
Well,
And then your eclipse is when the moon goes over the sun.
I saw your Snapchat and I was
It's also a car.
yeah, no, they
See, on the right, moon, you said the moon.
I watched the video. I tried to
There's like no moon line.
so they
It's
were
like a
over the line basically. On the side and there's a brick on the right. So I hit the curve.
Okay, here's some important stuff. Shh, y'all simmer down. Here's some important stuff on our ellipse. There's the equation for an ellipse. X squared over a squared plus y squared over b squared is equal to 1. And on an ellipse, the things that we're going to have to find are our intercepts. Okay, so this is going to have x intercepts. PTS, INTRCE, that's an E. X intercepts at A0 and negative A0. And then it's going to have y intercepts at 0b and 0 negative b. So you're taking the square roots of these things. Bless you.
Thank you.
Alright, so break out what you need on that one. Ready to do one and graph? Okay. Okay. Alright, I don't know if I have a fancy ellipse drawer on this. I may struggle like y'all, I'm not sure.
I have a fancy ellipse drawer. It's called my hand.
Oh, well, good for you, fancy shoes.
Because I can draw a circle, kind of. Okay, we can talk about that.
Okay, first off, before we start plotting some points on this one has not been scooted anywhere. There's nothing up here with the X or with the Y scooting it right or left, so that means it is going to be, can't say it has a center because it's not an equidistant, but it is, that is where our focus will be, is at the origin. Okay, so my X-intercepts on this, A squared is 4, so that means my A is 2, right? So I'm going to have an X-intercept at 2, 0 and negative 2, 0. My B squared is 25, so my B is 5. So I'm going to have a Y-intercept at 0, 5 and 0, negative 5. Okay, so we're going to put all those points on there. 1, 2, plus 2, 0, negative 2, 0, 0, 5. 0, negative 5. Okay, so I made mine, the spacing I did on mine makes it be an elongated looking thing. I could have spaced them out farther if I wanted to. Well, I do have
I
a,
got this one down.
oh, it doesn't go from the center though, okay. Well, that's gonna suck. Now, where are you gonna start from to get it?
Mine looks like a potato. That's mine.
I'll try the bottom, like
Yeah.
on the side, maybe.
Yep, that's it.
See, mine looks a little bit more like a potato. It's not brown. It's like a
Carrot. You gotta see. It doesn't look like a carrot. Alright, let's look at what one will look like if it's not centered at the origin that way. Okay, Everybody got what you need on that one? Alright, I've got x plus 4 squared over 16 plus y minus 1 squared over 36 is equal to 1. Okay, so on this one, I see that my x has a 4 added to it. On our x, remember our circle formula here, it's the opposite sign, right? So this is going to go to the left 4. 1, 2, 3, 4. I'll be looking right here. But then on my y, it's got a minus 1, so I'm going to go up 1. So that is actually going to be what's in the middle of my ellipse. Okay? Now when we look at our intercepts, they're going to change a little bit. Because normally here I would say, well, the square root of 16 is 4, so this is going to have intercepts at 4, 0, and negative 4, 0. That would be what I would normally say, right? But that's not going to be the case here. Because if I went 4, 0, 1, 2, 3, 4, I'd be way over here. Negative 4, 0 would be, see, that wouldn't be in the middle, right? So what am I going to do to figure out those intercepts? Any thoughts on that? Okay, well the center of the middle of my ellipse will be right there at y equals 1, right? Because it moved up 1. Normally, on this, let's look at the last one more time. This 2, 0 and 2, 0, that from that point was 2 away and 2 away. So if I have 4 from the middle, I'm going to go 4 and 4, right? Does that make a little bit of common sense? Whoops, wrong button, dummy. I got an answer, maybe.
Okay, that's good.
Okay.
Okay, how did you count that first lot that way? Because
1, 2, 3, 4.
okay, because 4 you went to me. Everybody went on school.
Okay, so from here, if the square root of 16 is 4, so from this point is where I'm going to do my 1, 2, 3, 4, and my 1, 2, 3, 4. Okay? So this one, b squared is 36, so that means normally I would be dealing with 0, 6 and 0, negative 6, but it's not going to be from 0, it's going to be from this point. So from there, I'm going to go up 6, 1, 2, 3, 4, 6.
Yeah, me too.
I've never done this. Okay, so these points are going to be what you connect to make your ellipse. Yeah, I think that was pretty good. That's probably my best work ever.
This is my worst work. That one's got some kind of Easter egg.
Hey, it's good. It's Easter Sunday.
What is Easter? I
Not
never
this
know.
Sunday, but next. Yeah.
Mine looks like an ornament, you know.
I'm going to show you one more thing after you get that one done.
What does it look like? Not ordinary. No, what? The way it comes down, you know? Okay, I don't look like it.
It looks like a circle.
Oh, because I did it wrong. I don't know. No, maybe not. I don't really know. Yes, it's because I know why. You know why? Because I spread these lines out more than I did these.
Yeah, if you're not consistent,
Yeah.
they get whopper job.
Yeah.
Yeah, that's it.
That's what happened.
Look at that.
All right, let's look here. You did do good.
Beautiful.
Good on that.
See, these are really good. Yeah, that's fine.
I'm just going to write two equations for you. There's number 1, x squared plus 4y squared equals 4. And number 2, 3x squared plus 3y squared equals 300. Okay. What was different about today's stuff that I don't know if you recognize it or not is that both variables were squared. We've graphed things where we've had one variable squared that made parabolas, but both variables were squared in this case, and that's your clue that it's a circle or an ellipse. No, I do not know how to graph these in your calculator. I think people have figured it out before, but I don't know how. They're not solved for y. Your calculator does things in terms of y. So it would take me more work to solve that thing for y than it would just to do the radius in the center. So I don't mess with that very much. My question to you is, what would those two equations be? Are those circles or radiuses, circles or ellipses, and how can we tell? Okay, I started this whole thing off by reminding you that on a circle, that center is equidistant. And that's important. If you're equidistant, that means your x's and your y's have to be the same distance from the center, right? So if I'm looking at that first one that I got written up there, I see I've got a 1 coefficient on the x, and I've got a 4 coefficient on the y. So very good. So those coefficients are not the same. So this one could not be a circle. So our only other option means it would be an ellipse.
Which is the potato.
Yes, the one that looks like a potato. Good. Okay, so this one here, I've got same coefficients. So that one would be a circle. So that's an easy way to check and see if you're dealing with a circle or an ellipse on what your coefficients are. Okay. Or potatoes, Mr. Austin said. That's good. All right, tomorrow's stuff is hyperbolas, which those are the things that look like, just show you what they look like real quick. They're the things that are like two curves that look like something like that. You've seen those before. We'll look at that tomorrow. Okay?
Are they really called hyperbolas?
HYPERBOLA.
This is called an hourglass.
Oh, I don't know. Hyperbole. It's a thing in the English.
Yeah.
That's why I'm like,
I can tell you.